Hi, good to be here with the WBA for a mid-2021 check-in. I'm responsible for the marketing at the connectivity group at onsemi. And as you know, onsemi is well respected for our industry-efficient solutions as well as Wi-Fi leadership. So the Wi-Fi 6 and 6E momentum obviously continues in full force, and our industry is already in the throes of getting ready for Wi-Fi 7 Plugfest in 2022. At the same time, there's a lot of buzz around edge compute and especially MEC, multi-access edge compute. Very often, this is in the context of 5G, with the thought being that 5G opens up the connectivity opportunity in premises where the work is being done. For example, an industrial floor. One reason often cited is latency, and with Wi-Fi 6E, some of these attributes are met. And as we look at the large installed base of IoT and edge devices, they tend to be Wi-Fi enabled already. So data is being created by us in our environment where we work or play. It can be a result of our interaction with machines and also from the equipment itself in the case of machine to machine. Edge devices are pieces of equipment that were built for a specific task, for example, an assembly machine. And then they've progressed to have compute abilities in them as well. So edge computing is really driven by two main things. The fact that there's a lot of data that would have otherwise moved across the network, and second, the need for a real-time response. Therefore, it is about placing the workloads as close to the edge where the data is being created and action has to be taken. All the data that's being generated needs to be transported to where action can be taken on it. And Wi-Fi plays a big role to make that happen. Unlicensed spectrum, diversity of vendors, high volumes, all mean cost-effective solutions at different price points for the job at hand. Wi-Fi 6 and 6E with the pillars of multi-user MIMO, OFDMA, and underlying algorithms to select the best channel, and value-added implementation on top of that, like headless onboarding, means that it's very often the first choice in cost-sensitive devices and high-volume machine-to-machine applications. On Semiconductor has a strong focus on power efficient sensors and solutions. So one example has to do with predictive maintenance. Sensors can be added to electric motors to measure temperature and vibration. Using a trained artificial intelligence model, it can then predict when the motor has or will have a bad bearing. The early warning helps service the motor before it fails. This predictive maintenance reduces line down time because the equipment is proactively serviced, which results in both cost savings as well as reduced efficiency loss. However, if you add more sensors, the gateways can then get overwhelmed with the increase in telemetry data. So in that case, really, we have two choices to alleviate this data and network congestion. More gateways could be added, or more edge processing could be pushed out to the end IoT nodes. And that's where Wi-Fi comes in. It helps move that data from those nodes to where action can then be taken. So in the previous example, the edge device was in a fixed location. Example, the sensor-enabled motor. And earlier I mentioned that edge compute was driven by the need to move lots of data and the value of a real-time response. Multi-access edge compute adds the element of mobility. In MEC, the device user could be anywhere. We cannot predict where the edge computer is located, so we install them on the network itself. For example, at the RAN, added at the base station to help drive the latency towards around 10 milliseconds. And 5G system architecture is a key part of MEC. The mobile system architecture is split into a central and virtual control panel, and it handles multiple user planes that can be deployed anywhere the IP network allows. And these user panels can be placed at microclouds, that could be managed by an operator, or at an enterprise with a dedicated MEC, and then also be deployed in combinations of dedicated radio, either Wi-Fi or cellular. So therefore, the technology is really access agnostic in the sense that it can be applied for cellular and non-cellular wireless networks. So the aim really is to reduce latency and ensure a highly efficient network operation and service delivery. And this is what makes Wi-Fi 6E a very viable player for this segment. So first we talked about, the role Wi-Fi 6, for example, was playing in edge devices. And then second, how Wi-Fi 6E can extend that franchise by being part of MEC, multi-access edge compute. There's a third way Wi-Fi is positioned to contribute, and this is via 5G convergence. Segments such as enterprise, industrial IoT, medical, and healthcare can have a mix of 3GPP only or dual radio and Wi-Fi only devices in a private 5G network. 3GPP enables convergence of both untrusted as well as trusted wireless LAN access with the 5G system. The WBA, for example, is doing a lot of work in this area with MEC 28. Wi-Fi, however, is already playing a practical role at the edge. It exists there. It is delivering, it meets varied use cases and price points for segments such as industrial IoT. And on semiconductors, Wi-Fi 6E designs are available today. And collectively, industry work is already being done to define Wi-Fi 7 features such as 320 megahertz channels, deterministic enhancements, as well as multi-link replication, all of which bodes really well for the innovation for us to create new solutions.